For most of human history, the scientific consensus was simple. The universe was an infinite, ageless void. It had no start date, and it would have no end. That static model held until Albert Einstein published his theory of relativity. His equations showed that gravity should be actively causing the universe to either contract or expand. Shortly after, Edwin Hubble looked through his telescope and observed galaxies actively moving away from each other in almost every direction. If every galaxy is drifting apart as time moves forward, rewinding the clock leads to a single, inevitable conclusion. At some point in the distant past, everything in the cosmos was packed together. The universe had a beginning. We call that beginning the Big Bang, which usually brings to mind a massive explosion of matter bursting out into empty space. But that mental image is entirely wrong. There was no outside space for things to explode into. Instead, the universe was all of space, expanding and stretching out into itself, everywhere at once, with absolutely no borders or edges. In its earliest moments, the entire observable universe was about the size of a football. It was an environment so intensely hot and dense that matter and energy were practically the exact same stuff. The complex structures we see today, planets, stars, and humans, were not forged in a fiery blast. They are the direct result of the severe drop in temperature that happened when space stretched out. In that initial blistering environment, pure energy converted into subatomic particles that flashed in and out of existence in tiny fractions of a second. Inside this chaotic soup, elementary particles called quarks were constantly colliding, destroying each other, and instantly reverting back into raw energy. For every matter particle created, an equal amount of antimatter was forged, locking them in competition. But as expansion continued, the scale tipped. Matter won by the narrowest margin, exactly 1,000,000,001 matter particles for every billion of antimatter. The two sides annihilated each other almost entirely, leaving behind only that tiny, solitary remainder of regular matter. That microscopic surplus is the raw material for absolutely everything that exists today. As space physically stretched to 1 billion kilometers across, the universe experienced its first critical drop in temperature. This cooling triggered a permanent phase change. The environment simply wasn't hot enough for quarks to freely revert back into raw energy anymore. Instead, these surviving particles were forced to slow down and lock together, binding permanently into larger, stable structures called hadrons, what we know as protons and neutrons. Keep in mind the scale of this timeline graphic. This entire sequence, from the birth of space to the formation of stable subatomic particles, happened exactly 1 second after the beginning of everything. As the universe reached 100 billion kilometers wide, the temperature dropped to 10 billion degrees Celsius. Now, the cold allowed most of those loose neutrons to decay into protons, creating the very first element, hydrogen. Thermodynamics drove this entire process. The simple act of cooling forced a violent sea of pure energy to freeze into stable building blocks of matter. Over the next few minutes, the rapid expansion settled into a quieter rhythm. Electrons latched on to the newly formed hadrons, creating an environment that was electrically neutral. The visual reality of the universe was now a vast, heavy expanse filled entirely with a thick fog of hydrogen gas. Because this dense hydrogen physically trapped and blocked visible light from moving through space, this cold, quiet era is known as the Dark Age. It took millions of years for gravity to finally pull and clump this cold hydrogen gas together under crushing pressure. When that pressure reached a critical threshold, the gas ignited, giving birth to the very first stars and massive galaxies. The intense radiation burning off these early stars boiled the surrounding stable hydrogen fog, dissolving it entirely into a charged plasma. This phase change cleared the fog. Visible light could finally travel freely across the vast distances of the cosmos, bringing the Dark Age to a permanent end. We can trace this sequence of events back to fractions of a second after the start, but the absolute beginning, point zero, before the stretching even began, remains a blank page. At that infinitely dense singularity, our physical tools are useless, and the standard laws of nature break down completely. To see past that wall, we would need to write a unified theory that successfully marries the mechanics of the quantum world with Einstein's rules of relativity. But even without seeing point zero, we know the definitive result of the expansion. The particles that froze out of that initial cooling eventually clumped together to form galaxies, the remnants of dead stars, and the Earth itself. We are not spectators looking at the Big Bang from the outside. Because every atom in our bodies was forged in the cooling debris of that early universe, we are simply the cosmos experiencing itself.